So class templates are a great way to provide flexibility and a bit of freedom in the implementation and usage of your classes whenever they are instantiated in your program. So here they give us, on this HackerRank page, it's a HackerRank challenge, they are giving us a definition of class templates, and they say they are generally used to implement containers. And whenever you create an instance of a class template, then you need to use template arguments. If you want to see what they look like, they look a bit like this. So here we have this class add elements. It's a class template, and we pass double as the template arguments. Here we pass int as the template argument, and here we pass string as the template argument. Now notice that it's the same class name because it is the same class, but we can pass it different template arguments. So why do we need to do that? If you check this sample implementation here, you have a class called myTemplates, and it is a class template. That's why you see this templates keyword right here, followed by the less than and greater than symbols, and in between those you have the keyword class, and then you have this term T. By convention we use T, but you can use any other keyword. You just have to be consistent in the implementation of your class. If you use T, you have to use T everywhere else. So anyway, here you have templates class T, and then in the implementation of your class you can reuse this. This T here serves as the flexible data type. So for instance, whenever we create an instance, of course the names are different. Here is myTemplates and here is add elements, but let's just say for the sake of arguments that they were the same class. So imagine that this was called add elements. Here, whenever we create an instance of the add elements class as an object, obviously, and we pass it, for instance, this double data type as a template argument, then T would represent a double, meaning that here our member variable called elements would be of double data type. If we pass int as a template argument, then the member variable element would be of type int. If we pass string as the template argument, then the member variable element would be of class, would be of type string. So you get the idea. Like, you don't have to restrict or force the user to use a specific data type. It's pretty flexible. So the user can decide what data type they want to use by passing it as a template argument, and then in the implementation of your class, you can use it to do whatever you want. So here, obviously, I guess we're dealing with numbers, because then we have this method called divide by 2. It doesn't really make sense to divide a string by 2 the way they are doing it here, but I hope you get the idea. Now we need to look at this here, which is called template specialization. I'm going to leave a link to that page from Geeks for Geeks. I think they have done a pretty good job of explaining, and they give this example here. Let me zoom in. But here, for instance, you want to apply a sort function. You have a class template like I just explained, but let's just say you want to use a different sorting algorithm if it's the array contains char elements. In this case, you would use an empty between the less than and greater than symbols. You won't put anything. You won't put that class T. You will leave this empty, and then in your class, you would append this to your class name. So if it's char, you would append char to your class name. I think here we can see another example whereby you can see, like, after templates, there is nothing in between these signs right here. But after the name of the class myTemplates, then they have this char, because this class is supposed to be specialized. The implementation here is supposed to be specialized for characters. So here they are not using T, for instance, like we saw here. They're specifying that they want to use char. Here again, they specify char, and then here the return type is char. So this class template is specialized for characters. And this is what we call template specialization. So let's go ahead and jump straight into the code here. I'm just going to implement or apply one or two of the constraints here, because we don't really need to apply this to pass this test. But you guys can do it. You can do all 4 of them just for exercise. You can skip some part of the instructions, because we don't need to worry about really how the input is shaped. You can see here that, for instance, you have number 3, meaning that there are 3 lines that we need to work on. Then the first word refers to the data type. So this is a string, John Doe is a string, 1 and 2 are ints, and 4.0 and 1.5 are floating numbers. And here we need to add them up together. So if we add John and Doe together, we are concatenating the string, so we get this in one single string. If we add 1 and 2 together, then we get 3. If we add 4.0 and 1.5 together, then we get 5.5. So we only need to worry about creating a class template, and we're going to return for the method add. We're going to have a method called add in our class, which will return elements 1, which we pass to our constructor, and we are going to accept another argument for the add method and add this to element 1 and return it, so that we get something like what I've just explained. 1 and 2, for instance, if we call add and we pass in 2, then we will return 3. That is if we already stored element 1, which was 1 here. So when it's string, then we need to create a method called concatenates and return the concatenated string. So you can see here we use adds methods. We can use that for our class templates, but then we can create template specialization for this right here, so that we can use a method called concatenates rather. And this, in fact, is what they require us to do, because you can see here they say out of the following 2 elements, you have to concatenate or add the second element to the first elements. And here again, they specify you need to write the class templates add elements, which is what we're about to do. And it has a function add for giving the sum of ints and float elements. You also need to write a template specialization for the type string with the function concatenates to concatenate the second string to the first string. So let's get started right away. All right, so instead of going ahead and typing class as a first thing, like I have shown you in my previous videos, the first thing we need to type here is the template keyword, and then class T, and we close this. Then we move to the next line, and here we write class. The name of our class here is add elements. So forget it's a semicolon. And we're going to have private. We don't need 2 member variables, because the second member variable is going to be passed through our add function right here. So we only need 1 member variable. Now next up is the constructor. So the constructor is going to be add elements, and whatever we pass to our constructor is going to be assigned as a value to A. So I'm going to have TB. And if you watch my previous tutorial, when I think I talked about inheritance in the first video, I said that instead of writing something like A equals B, which will be perfectly valid, you can have something like this. Okay, so next up, let's create our add function. And it's going to take, again, it's a parameter of T type. The return type is also T. So again, it all depends on what template arguments we pass. We pass the instance of our class here when we create an object. And we are going to have, we need to apply one of the constraints. So I'm going to apply this one right here, the first one. So I'm going to say this: if n is greater than or equal to 1, and n is less than or equal to 5 times, I'm going to use the power method, which is, I think it's from the CMath library. That's why we have the CMath header file here. So I'm going to say to the power of 10 to the power of 5. That's how we use it, okay? So this is the base, this is the exponents. And because we only have a single statement next up, I don't need curly brackets. I can directly say return A plus n. Otherwise, return, I'm going to say return 0 otherwise. And finally, if you watched some of my first tutorials on classes and objects in C++, I said it was a good practice to have a destructor. all right? But I'm going to leave that empty. Okay, so now let's work on template specialization. And this is going to be empty. I'm going to have again class add elements. And this is going to be specialized for strings. You see here, after the name of my class, I have string right here. Here, I had class T after the templates keyword, and I had nothing after the name of the class. So you note the difference right there. Now again, I'm going to have private, and I'm going to specify that I want a member variable of string type. And finally, I'm going to have public. I'm going to have a constructor. It's going to take a string as an argument. I'm going to say string B. I'm going to use the same notation as I did before, where I say A. The value of B should be assigned to A. So this is initialization, but an elegant way of initializing your member variables. Next, I have a function called Concatenates. It returns the string. That's how we have this string that I read there. And it takes a string as an argument. I'm going to call that string S. Now I'm going to apply this constraint right there. If the length of the string, which means the number of characters that the string contains, if the length is greater than or equal to 0, or it's less than or equal to 10, then we can go ahead and concatenate the string. So let's apply that. We're going to call the .size method to get the length of the string. I covered that, I think, in one of my previous videos when I talked about strings in C++. So I'm going to say if the size is greater than or equal to 0, and the size is less than or equal to 10, then again we have a single statement, so no need for curly brackets after the if statement. I can say return A plus S. So again, because we're using strings, we are basically using the same kind of command, the same statement. Here we had A plus N, here we had A plus S. If this condition fails, let's just return our initial string, which is A. Now again, you might ask, why the heck are we using the same statement, but then here we have template specialization, and here we have a template class? Couldn't we do the same thing? But note the difference here in the implementation. First of all, here we return the initial string. Here we return 0. And secondly, the condition is different. Here we check between 1 and 50,000. And here we check the length of the string. So we have really different implementations. But this one is specialized for strings. That's why we can call the .size method on the string parameter. This one it's more flexible, but expected to be used with numbers. You get the points. And finally, let's have a destructor, sorry. So I'm going to have tilde symbol called add elements, and it's going to be empty. Let's run this code. I think it's going to run fine. We pass the test. Let's submit this code and make sure that we pass all the test cases. And the time limit for this challenge is 4 seconds. I think they are talking about the execution time. And indeed, we just passed all the test cases. So that's it for this video. I'm not going to stretch it any longer. If you have any questions, please make sure you drop them in the comment section. Give this video a thumbs up. Please subscribe to support this channel, and turn on your notifications by clicking on the bell icon. I'll catch you next time. Bye.